Hello world, this is Miso here from misogames.com, and today we're doing our first video, and for that we're going to be starting a series where we're going to be cracking open 6 of these Brothers War booster boxes that I got and hopefully being able to make a profit on that. I know what you're thinking right now, like making a profit on booster boxes, never do that, just buy the singles, but today, with some fancy math and mental gymnastics, I'm going to justify why my gambling works so I can continue being a degenerate and not feel terrible about it. So today's quick slide over this is what is EV and why does it matter for Magic or Gathering, Pokemon, Yu-Gi-Oh, or anything that really has booster boxes. So before we get to a more complicated example, let's just take a simple game and then we'll expand on this later on. So just a coin flip, heads or tails, 50% chance of heads or tails, and then let's attach a random monetary award to it. So let's say when you get a heads, you win $20, and then when you get tails, nothing happens. To calculate the expected value of this, we basically just get the odds of something happening in terms of like a decimal, and then multiply that by the value that you get there. So in this case, 50% chance of a heads and getting $20, and add that by the 50% chance of getting tails and receiving nothing, and you'll have your expected value over enough runs of this game. So $10 EV on average with enough plays of this simple game. But now let's take this one step further. What if it actually costs money to play this game? That's where, assuming we can get infinite of these opportunities, it could get interesting. So again, on average, we're getting $10 per game for this example. That means when it costs $10 per play, we're just going to keep putting $10 to wherever this game's happening and then getting $10 back over the long run. Nothing really happens. That's boring. But yeah, that's what happens when $10 per play. But if it actually costs less than $10 a play, for example, with $9.99 per play, over a long run with enough plays of the game, we'll be making 1 cent per play, which is basically an infinite money glitch. Just keep playing this game, we'll get infinite instances of gaining 1 cent per play. We're Leonardo DiCaprio here. We're making fat stacks. But here's the opposite. So let's say it actually costs $10.01 per play. That means over enough of these runs, we're going to be losing 1 cent per play, and that's not good. We don't do that here at misogames.com. We only make money. So now let's extrapolate this and take another game where there's probabilities and a cost of playing, like the Casino of Magic the Gathering. So again, there's some probability of receiving an X number of rares and commons for a booster pack. Oops, sorry. And then here is an example for Call of Mana. We might have a 70% chance of receiving a booster pack that has, I don't know, 1 rare or mythic and 1 foil, and then a 10% chance of getting one with more than that, with like the list or something else. And then in each of these slots, you can see, so like say the common one here, we have a rough idea of how many of each specific common card will receive on the long run. So in the case of Call of Mana here, in the 1 common slot, we have a 1.23% chance of getting an Agency Coroner or Behind the Mask. So once we have the specific value of the cards themselves and the expected odds of getting each of those cards, we can basically calculate the expected value of each slot, use that further in a bigger level, the value of each booster pack, accounting for all 14 of its slots in a play booster, 15 for draft, and then go further and get the whole value of the box itself, since each of those is a probability that we can account for and sum up together all at the end. TLDR, known probabilities, known card values, we can get an EV, and interesting things can happen. So like for example, on occasion, even with tax, the price of a booster box might actually be less than the expected value of it. So for example, I'm going on a venture with Brothers War boxes, got these in Canada, this is in CAD, $769 on sale, for a total cost of $1.28 per booster box. And what's the EV of this? Let's take a look. So Here to construct the EV, I'll be using two resources I found online. First is Scryfall. Let me go back here, where we can get the prices of any card we see here. Like one I like, I don't know. What's the card I like from draft days? I don't know. This guy looks cool. Myers Shield of Argiv. That card is worth 18 USD. Pretty good. And then from MTG.WTF, we have we have, I guess, different booster packs, the slots that are contained inside it, like the commons, rares, mythics, or the retro artifact included. And then within each slot, it shows the probabilities of it. So, for example, for the common slot here, we'll have a 99 with 0. Almost a 1% chance of getting an Arrow slot Cavalry or Ashnod's Intervention. And then let's say we grab the expected value of this common slot here, like getting 1% times the probability or the price of a Agravian Cavalier. It should be 6 cents, I believe. And then we'll do that for all the other commons, and maybe the whole common slot itself is worth, I don't know, 6 cents on average. Then for a particular booster pack, we would multiply that by the number of each of those slots that appear. So there's 10 cards coming from the common sheet. So that would be 6 cents times 10 for 60 cents value in this slot over here. And then we could pretty much do the same thing for the uncommons and commons, for the rares and mythics, and then the special retro artifacts. By doing that, we'll have a total value of each slot, the number of cards in each slot, which constructs this particular booster pack, the ones that are on a 41% chance, and then we can do the same for all the other variations of the booster packs. And once we add those all up together, we'll have the full value, expected value of the booster box. So that's a lot of math. We don't want to do that by hand. We don't do that here. Here I have a quick Python script. I'm not going to go into the details, but it basically pulls all the different products available on MTG WTF, goes into each of them and grabs all the probabilities of each of the cards, and then does the proper expected value calculations at the slot level, moves that to the booster pack level, and then multiplies that by the total number of booster packs per box, since some have more than others. For example, draft booster boxes have 36 cards per pack, and then I don't know, set have 20, I think. Collectors, I don't even know, 12 or something. And then doing that, we can pretty much get the expected value of any Magic the Gathering product, which is actually what Mox Alpha does, but that costs $40 a month. We don't do that here. We make it ourselves. So in the case of Brothers War, we're doing Brothers War Draft, and then just a quick note for this output over here, I actually exclude any card that costs less than 25 cents, since it's so hard to sell. But we have an expected value of $141 USD. That's more than the cost of my booster boxes. So theoretically, we could be making some money once we break the whole box apart, open the stuff up, where the singles have a value that exceeds the value of the sealed product here. An excuse to gamble, my favorite. So let's go back to the slides. Yep, so just copy that over here, 141 USD expected value, which is about 182 CAD. I'm just going to multiply about 1.3. It's a little bit of an underestimation, but we'd rather be safe than sorry. But that means we might be making $50 profit per booster box, making money and gambling. But of course, there's some caveats about this. Like a lot of the value might be locked behind some lower value cards. Like, sure, I took up the 25 cents ones, but there might be a lot of hard to move 26 to 99 cent cards that aren't easy to sell. And then this is only ever an average. I'm only doing 6 booster boxes, which isn't really a lot. This only comes into fruition with a lot together. But either way, I'm going on it. This is the gambling quest that we're going on. With a total cost for those 6 booster boxes at $769, we're going to try to exceed that, which marks the beginning of this booster box unboxing journey. So come along with me, and once these cards are all pulled together, you can find them at misosoupgames.com.